we will start the integumentary system. You know that human body consists of 11 systems, and integumentary system is one of them. First, we'll see the parts of this system. Then we'll talk about the functions of the integumentary system. Then we will see the main part, which is the skin. Okay? So skin is the main part of the integumentary system. We'll see the structure of the skin. We'll see different types of skin. We'll see the glands of the skin. Then we'll talk about the structure of epidermis and dermis. Those are two layers of the skin. Skin has two layers. Outer layer is called epidermis and inner layer is called dermis. Okay? So we'll see the structure of epidermis and the structure of dermis. We'll also talk about water loss. Different ways water get out from the body. We'll see how we lose water from the body. So the parts. The main organ or part is the skin. Other structures, those are called accessory structures, include here glands of the skin. Only the glands, those are present in the skin, like sweat glands, sebaceous glands, and nails. So these are the parts. Functions. Your skin provides three types of protection to your body. Chemical protection, biological protection, and mechanical protection. Three types of protection. Chemical protection by secretion of low pH menthol. Low pH means what? Acidic or alkaline? If it goes below 7, acidic. Very good. So low pH means acidic, right? So your skin secretes acidic secretion, and that acidic secretion can kill or retard microorganisms. So that's how your skin protects chemically, by secreting chemicals.
It can kill things, it kills what?
Microorganisms like bacteria, virus, right? Then biological protection. In your skin, you have phagocytic cells. Phagocytic cells do what? Engulf, right? Phagocytosis. So, two types of phagocytic cells are present. Macrophages, you all know that, and dendritic cells. Both do phagocytosis. So, they can engulf the microorganisms or antigens and destroy them. And since these two cells are present in your body, those are the part of your biology, right? Part of your body. So, biological protection. Make sense? Everybody has those cells in the skin and other tissues too.
And you said they eat. What do they eat though? Just
What is the purpose? Eating the microorganisms that try to invade into your body, okay? Or antigens. Physical or mechanical protection. Two important chemicals. One is called keratin and another is called glycolipids. These two chemicals are present in the skin, and these two chemicals do what? Prevents water and water soluble substances from entering into the body through the skin. So these two chemicals make the skin waterproof. Make sense? Make the skin what? Waterproof. So water and water dissolved, substances cannot enter into the body through the skin. You all know when you sit in a bathtub, okay, for a long time, water doesn't enter into the body through the skin, right? Although if you spend long time there, sometimes, right, or you are in swimming pool, water doesn't go into the body, makes sense, through the skin. So that is a protection. Otherwise, water, water has microorganisms. If you see, pool water or, water under microscope, often you will see microorganisms that we don't see, right? But water has a lot of microorganisms, can be dissolved, and other chemicals. If water can easily pass through the skin into your body, then microorganisms will easily also enter into the body, right? But that doesn't happen because water proofness is given by these two chemicals. Sometimes, if you stay a long time, you are probably, you wanted to say that you see kind of, but that happens, but still water cannot easily enter into the body. So, those are three types of protections given by the body, given by the skin. Regulation of body temperature by two ways, or two means your skin lowers the body temperature. If body temperature increases, all of you know what happens? Sweating occurs, right? When body temperature goes up, sweating occurs from the skin, right? And you know that sweat has water, and that water takes a lot of heat out from the body, because water has what? High heat capacity. You remember that? Water has high heat capacity. That means small amount of water can take a lot of heat out from the body. Make sense? So when sweating occurs, water gets out from the body, and that takes a lot of heat out from the body. That lowers the body temperature. That is number one. Number two, when body temperature increases, vasodilation occurs in the skin. That means in your skin, blood vessels do what? Dilate. Make sense? So now you tell me, if blood vessels dilate in your skin, more or less blood will flow there? More, right? So more blood circulates in your body surface, in your skin. Make sense? And from the blood, heat can easily get out, released to the outside. So by those two ways, your skin lowers the body temperature. Number one, by sweating. Number one, by increasing the blood flow. Is it clear? Increasing the blood flow in the skin. Cutaneous sensations. In your skin, you have cutaneous receptors. What are the cutaneous receptors? I mentioned before, pain receptors, touch receptors, temperature receptors, right? And because of those receptors, you have those sensations. Make sense? If someone touches, you can tell, right? That you got a touch. If something bites, you feel pain, right? And if something hot or cold touches your skin, you can tell that. So, why? Because you have those receptors in your skin. Okay? Now, you understand that how important those receptors are, because those receptors help us to detect the things, right, around you. If the room temperature increases, you can detect it, right? Your body can detect it. If something very hot touches, you will move your hand away, right? Body away. You will go away to protect you. So, very important function, having cutaneous sensations. Metabolic functions. I mentioned before that with the help of sunlight, your skin produces a chemical that is called cholecalciferol. You must remember that. Calciferol, which is an inactive vitamin D, precursor of vitamin D, and that cholecalciferol is taken to the kidneys, okay, to the kidneys, where it is converted to calcitriol. Calcitriol, which is an active vitamin D. Okay, so blood takes the cholecalciferol from the skin to the kidney, where it should go to the kidneys because kidney has the enzyme that will convert cholecalciferol to calcitriol. Converting enzyme is there. So you will now see that your skin helps in the synthesis of vitamin D, which is very important chemical. Excretion. Small amount of metabolic wastes and salts are excreted through the sweat. So, mainly nitrogenous wastes and salt, sodium chloride. That's why the taste of sweat is salty, you know, slightly salty. Okay, so those are the important functions of your integumentary system. Now we'll see the types of skin. We can divide the skin in two ways. One is by thickness. By thickness, we divide the skin into thick skin and thin skin. Okay? Thick and thin skin. Another way we divide by looking at the presence or absence of hair. Hairy skin and non-hairy skin. So those are two ways we divide the skin. Thick skin is present only in few areas. For example, your palms of your head, soles of your foot or feet. So rest of the area of your body is covered by thin skin. So the main difference between the thick and thin skin is the skin has, first if you see the structure of the skin has two layers. Outer layer is called the epidermis, and inner layer is called the dermis. So skin has how many layers? Two. Outer epidermis, inner dermis. Under the dermis or skin, you have another layer which is not a part of the skin. Remember, this layer is not a layer of the skin. This is under the skin. It is called hypodermis. Okay, hypodermis or subcutaneous layer. Sub means what? Under. Cutaneous means skin. Remember, cutaneous means what? Skin. When we say cutaneous receptors, that means skin receptors, right? So subcutaneous is not a layer of skin, it is under the skin. Understand? Yes.
Is this the thin skin that you're drawing, or is that the thick?
I'm just talking in general, the layers of the skin. Then we'll talk about thick and thin. Okay? So skin has how many layers? 2 layers. Outer epidermis, inner dermis. And under the skin you have hypodermis, where you have lot of fat or adipose tissue. Adipose tissue or fat. Okay. Now, if you see a thin skin epidermis, it has 4 layers in thin. In thin skin epidermis, you have 4 layers. In thick skin epidermis, you have an extra layer. That means how many? 5 layers. Okay. So thick skin has 5. This is, if you see from inside to outside, this is 1, 2, 3, 4, 5. Okay. Dermis has only 2 layers. Okay. Dermis has only 2 layers in both thick and thin. So this is number 1 from inside. This is number 2. This is dermis. Okay, this is epidermis. Okay. Now, hypodermis has a clinical significance. What is that? Subcutaneous injection is given into hypodermis. Why we inject drug subcutaneously? Why we give subcutaneous injection?
Is that more where the capillaries are?
In fat tissue, you have less capillaries,
Less capillaries.
less blood flow, okay, than muscle. So blood takes the drug from here slowly because you have less blood flow. Make sense? Less blood goes there, so that drug is taken into the blood slowly. Make sense? So if you want any drug to work for a long time, you will inject subcutaneous. Make sense? So drug will slowly enter into the blood. So it will stay there for a long time and will work for a long time. Make sense? Like insulin. We don't want to take insulin every hour, right? So when we inject, it works for several hours. Make sense? So that's why we do subcutaneous injection. Okay? Because less blood flow is here. Now, if you want any drug to act immediately, which route you will prefer? Intravenous. Directly into the vein, into the blood, right? It will go immediately into the blood. So, immediate action. Now, if you want not too fast, not too slow, then where you will inject? Intramuscular. Into the muscle, right? Where you have more blood flow than the fat. Is it clear? So blood, lot of blood circulates there. Anyway, so that is subcutaneous injection given into hypodermis. Some structures of the skin. The skin has glands, 2 types of glands, sweat glands and sebaceous glands. Okay. Skin has hair follicles, hair roots. Skin has receptors, free nerve endings, and corpuscles. Those are the receptors. Receptors are located in the nerves as well as inside the corpuscles. Blood vessels and tiny muscles. Those are called erector pili muscles. Okay. Now, one thing you should know that almost all of these structures are present in the dermis. So, these structures are present in the dermis. And the dermis only is vascular. That means blood vessels are present only in the dermis. No blood vessel in the epidermis. So epidermis is avascular. Epidermis is avascular, that means no blood vessels. A means absence, and dermis is vascular. Okay, has blood vessels. Now you can ask me, then how the cells of your epidermis gets oxygen, gets nutrition if there is no blood vessel here? By diffusion from underlying dermis, oxygen and nutrition enter into the epidermis. By what? Diffusion. Okay, so these layers get oxygen and nutrition from underlying dermis, where you have the blood vessels. Okay. Now you tell me, if from underneath dermis nutrition and oxygen enters into the epidermis, which cells will get more oxygen and nutrition, which cells will get less? These cells will get what? Less or more? Less. And these cells will get more. Make sense? Simple. So that's why in the outermost layer of epidermis you see many dead cells. Make sense? Many dead cells are there. Anyway, so those are the structures you will find in the dermis of the skin. Now, what are different types of cells present in the layers of the skin? Most common type of cells are keratinized squamous cells. How many of you remember squamous cells? Remember that? Flat, right? Flat cells. And when the flat cells, squamous cells, make many layers, that tissue is called what? Simple or stratified? Stratified squamous, right? So, you have many layers of flat cells, stratified squamous. These are all flat cells. Squamous cells form many layers. And most of these cells are dead cells, but they are filled with keratin. You remember I mentioned when I talked about the mechanical protection, I said two chemicals, keratin and glycolipids. The keratin fills these squamous cells. Okay, so that's why we say keratinized. Make sense? Squamous cells, because those cells are filled with what? Keratin. Make sense? And keratin gives what? Waterproofness, right? As well as keratin gives the toughness of the skin. Okay. So most of the cells are keratinized, stratified, squamous. Other cells. What are the other cells present in the layers? Keratinocytes. Keratinocytes. See the name. Cyte means what?
Yeah.
Cyte means cell. Cyte means cell, right? So keratinocytes, the cells that produce keratin. Melanocytes are the cells, right, that produce what? Melanin. So, why melanin is important? Because melanin gives the color of the skin. Not only that, melanin is a pigment which protects your body from UV radiation. Okay, melanin has then two functions, I will say. One is gives the color of the skin, right? And number two, what? Protects the body from what? UV radiation. Okay, melanin forms a shield against UV radiation. So UV cannot pass through the skin. Now, anyway, so keratinocytes produce what? Keratin, right? That highly specialized protein that gives the waterproofness and toughness. Instead of toughness, I would prefer the word I was looking for, durability. Durability. Okay? Your hair has a keratin that is different than the skin keratin, but it is also keratin, and you know that hair doesn't destroy easily, right? Even after death, you will see the hair remains intact for a long time, many years.
What's
okay?
that word you said?
Durability. Did I pronounce correct? Okay. So the keratin gives that function, waterproofness and durability. Now, dendritic cells. I have already mentioned dendritic cells have phagocytic action. They can engulf. So that is another type of cells. Tactile cells, touch receptor cells. So those are some other cells present in the layers of the skin. Now here you see two types of cells. Those are related to keratin. One is called keratinized cells. These are the keratinized cells filled with keratin. These are squamous cells. Another is keratinocytes. Keratinocytes. Both are present in the skin. Keratinized are the cells, squamous cells that filled with keratin. Keratinocytes are the cells that secrete keratin. So what happens is, see here, keratinocytes produce and secrete keratin, and that keratin molecules enter into the squamous cells and fill the squamous cells, and these are called keratinized cells. So this is keratinized cell, this is keratinocyte. Now this process, how the squamous cells get filled by keratin, that is called keratinization. Makes sense? So keratinization is the process how the squamous cells get filled by keratin. So those are the cells. Here you see the structure of the skin. So you can see the outer epidermis in the left side and inner dermis. Dermis is much thicker than epidermis, but it has only how many layers in the dermis? 2, right? Epidermis has how many? 4 or 5. In thick skin epidermis, you have how many? 5. In thin skin, 4. Okay? So, those are the layers. If you see the dermis, what are those 2 layers? You see here, I told you that dermis has 2 layers, and inner layer is much thicker than the outer layer. Inner layer is called the reticular layer. So inner reticular, outer layer is called papillary. Papillary layer. Which one is thick? Reticular, much thicker, right? So reticular gives about 80% thickness of dermis, and papillary gives about 20% thickness. Okay? So these are the two layers of the dermis. And two layers are formed by two different types of connective tissue. Inner reticular is formed by dense irregular. How many of you remember dense, regular, irregular? Should not forget, right? I think almost everybody remember. Two types of dense, right? Regular and irregular. So dermis, inner layer, reticular layer is formed by that dense, irregular connective tissue. Make sense? Outer layer is formed by loose areolar. You must remember loose areolar connective tissue. Remember that? You saw under microscope two types of fibers, red collagen fibers, right? And thin, dark, hair-like fibers are called what? Elastic fibers. Remember that? So loose areolar forms the papillary layer. Dense irregular forms what? The reticular layer. Is it clear? Now you tell me which layer is soft and which layer is very hard. This layer is what? Hard, right? Dense, heavily packed fibers, right? Hard. And this is loose, soft. So lesion occurs in this layer of the dermis. Inflammation occurs in the papillary layer. Now you understand why, right? Because this layer is soft and can easily get damaged. Okay? So dermatitis is the inflammation of the papillary layer of the dermis. Most of the cases, this layer is very tough and inflammation doesn't occur here. So dermatitis, the word used to indicate the inflammation of the papillary layer of the dermis. Okay? Okay, now you see most of those structures I have mentioned are present in the dermis. What are the structures? You can see here two types of glands, sweat glands and sebaceous glands. Sweat glands are like coiled tube. So like this. This is coiled tube, and from that a tube or duct goes to the surface of the skin. So this is the skin surface. This is the sweat gland. Sweat gland, okay, like a coiled tube, and this is called sweat duct. And this is the pore opening, sweat pore, and this is the skin, okay, surface. So sweat gets out. In winter, in cold weather, more or less sweating occurs. Less. Almost no sweating, right? In cold weather. Why? You see this duct that takes the sweat out will constrict, shrink, constrict, okay? So the sweat will not be able to get out. Make sense? So that cold weather or cold temperature constricts the duct. Sebaceous gland is attached to the follicles. So you know here root, here follicle, then the shaft. So this is the shaft. This is the surface of the skin. This is the follicle. This is the root. Shaft. Cool, right? But anyway, so the sebaceous glands grow from the follicles. They grow from the follicles. That's why you'll see they are attached to the follicles. Okay? And the secretion is oily. This sweat gland secretion mainly watery secretion. Another type, there are two types of sweat glands. One type causes water-like secretion, highly watery. Another type is oily. But sebaceous gland secretes sebum is the chemical that is highly oily. Okay. So those are two types of glands. Then you see the corpuscles. These are Pacinian corpuscles. These are pre-nerve endings, blood vessels, arteries, veins, tiny muscles, erector pili muscles. These muscles help in the erection of hair. So if this is hair lying on your skin, right? When that muscle contracts, you see this is the muscle here attached. So it pulls like this. So the hair erects. Make sense? So erection of hair. Goosebump. You know, some animals, you know, they can erect the hair a lot, right? Like cats, when they fight, you have seen porcupines, cat, they can erect, right? Here to show the opponent that I'm big, don't come close to me, okay? Anyway, so those are the structures. Now we'll see the layers of the epidermis. I said that thick skin epidermis has 5, thin skin has 4. So what are those layers? Okay, let's go over that. So if we go from inside to outside, this is the innermost layer of the epidermis, and this layer is called stratum basal or basal layer. Stratum basal or basal layer. And this layer is formed by usually a single layer of stem cells. So these cells are stem cells. Stem cells usually form a single layer in stratum basal. Stem cells do what? Quickly create cells, right? Quickly multiply, mitosis. You know mitosis, cell division, right? So the stem cells can quickly multiply to produce new cells. While your skin needs to produce continuously needs to produce new cells. These cells die, right? You remember I said that? Outermost layer cells die. So you need to create new cells. So from the innermost layer of dermis, these stem cells produce new cells. And the new cells start to move up. And it takes about 25 to 45 days. 25 to 45 days for a new cell to reach to the outermost layer. Okay? So that's the journey. That's why this stem cell layer or stratum basale is also called stratum germinativum. The term germinal cell means what? Those cells can produce new cells. Stem cells. Another name of a stem cell is germinal cell. Then next layer is called stratum spinosum. If you see the cells in this layer, the cells have spikes or spines, you know, the sharp processes. So that's why it is called Stratum Spinosum. And in this layer, you have dendritic cells. Dendritic cells do what? Anybody remember? Engulf, right? You remember I said dendritic cells do phagocytosis, okay? Also, in this layer, you have plenty of melanin pigment. Plenty of what? Melanin pigment. Melanin is brown to dark colored pigment. Brown to dark. And I told you that melanin has how many functions? Two. One is giving the color of the skin, and another is very important, protecting against UV, right? So that Stratum Spinosum has abundant melanin granules, and melanin forms a shield against UV radiation. Okay, next layer is called Stratum Granulosa. You see, all these make sense. Why it is called spinosum? Because the cells have spines, so spines. This layer is called Stratum Granulosum. Why? Because the cells are filled with granules, two types of granules, keratohyalin and lamellated granules. You see the names, keratohyalin and lamellated granules. That's why this is called granulosa. Stratum granulosa. Okay. These granules are very important. They give the waterproofness. Okay. Because first one has keratin in it, keratohyalin. These two both give the waterproofness. Next layer is stratum lucidum. This layer, remember, is only present in thick skin. That's why thick skin has 5 layers, because this layer is only present in thick skin. Stratum lucidum. This layer is transparent. That means it looks like a thin glass. Okay, transparent. Lucidum. Only present in thick skin. But remember, although this layer is only present in thick skin, absent in thin skin, the thickness of thick skin is not given by this layer. Thickness of thick skin is not given by this layer. Make sense? It has nothing to do with the thickness. Then outermost layer is called Stratum Corneum. Stratum Corneum. This layer is very thick in thick skin and gives the thickness of thick skin. Stratum corneum. In thin skin, this layer is much thinner. Make sense? So, which layer is very thick in thick skin? Stratum corneum, this layer. And this is responsible for the thickness of the skin. Okay. And this layer is formed by many layers of squamous cells. Most of these cells are dead or alive? Dead cells. Many layers of dead squamous cells. You remember I said that? And they are filled with keratin. So these are keratinized, stratified squamous tissue or layer. And you know that keratin gives two things, two functions. Can you remind me? Waterproofness. Number 2, durability. Right? So these cells are heavily filled with keratin. Make sense? So those are the layers of the epidermis. If I ask you, what are the layers? These are the layers. Which layer is absent in thin skin? stratum lucidum, right? Which layer looks like a thin glass? That's the lucidum, right? What are the two granules present in granulosa? Keratohyalin, lamellated granules. Spinosum layer has what kind of cells? Dendritic cells and melanin granules. What are the functions of melanin, right? You already know. Makes sense? So those are the questions. Which layer has stem cells? Innermost, right? That's the stratum basal. Also called what? Stratum germinativa. Germinal cell layer. Okay? Or stem cell layer. How long it takes from the innermost to the outermost a cell to travel? 25 to 45 days, right? So remember those things I mentioned. Here you see the stratum corneum, outermost layer of epidermis in thick skin. You see how thick it is. This is in thin skin, stratum corneum, much thinner, right? So that gives the thickness